Good morning, good afternoon, good evening. Welcome to the sixth webinar of Excelero this year, how to architect low latency storage with NVMe at petabyte scale for AI and machine learning workloads. By number of registrations, this is the most popular webinar we've run so far. I'm not sure if that's because of the topic or because of the two good-looking speakers we have for you today, although you can't really see that. For this webinar, I have a special guest, Stefan Vervaat from Western Digital. Stefan is solutions leader at the data center system business. He's got decades of storage experience and more recently became Excelero's ally for our joint NVMe solution. Stefan will be joined by Josh, who most of you probably already know. Josh is our VP of products at Excelero, and he has even more storage experience. In today's webinar, you will learn how to implement storage for high-performance workloads such as AI and machine learning, where low latency at scale is crucial to stay competitive. We'll also introduce to you a new solution of Excelero with Western Digital that addresses exactly this challenge. Before I pass it over to Stefan, I would like to share a couple of things though. Everybody but Stefan will be on mute, but we do want the webinar to be interactive. At the bottom of your UI, you should see a Q&A button. Feel free to post as many relevant questions as you want. We have a team here that will be answering the questions, and the most interesting questions I will save to the end so that we can have either Stefan or Josh answer them. With this, enjoy the webinar. Stefan, the floor is yours.
Thank you, Tom. Welcome, everyone. Good morning, good afternoon, good evening. I'm happy to join Excelero in today's webinar. First of all, let me just walk you through what we're trying to accomplish today. One, we talk a little bit more about the ML AI problems most of you probably have known already, but there's some challenges there in storage, and we'd like to, show you what we can help you with today with this joint solution. So we'll go a little bit through the Excelero plus Western Digital offering, and then tell you a little bit more how it works. We have some performance numbers that we'll walk through, and then also some case studies on how customers have deployed this. So first of all, I work for Western Digital, and even at Western Digital, it's very well known that to stay competitive in the marketplace, you have to stay current with the latest technologies. And as you look at how data is growing today, there's new ways that data is being monetized, obviously, in different ways. And as we say at Western Digital, data is the fuel, and ML AI is the engine. So you'll see that in different use cases. But even at Western Digital, we ourselves are applying machine learning at the edge in our data centers to optimize our efficiencies as we manufacture drives. And it's not just the challenge is not just collecting the data, but it's finding the right way to actually monetize it and turn it into machine learning models that we can then apply at the edge through inferencing, or actually in the data centers itself to optimize our tests that we do on the drives. So with the growth of data moving even higher, right? As you can see, typically we're seeing 40% data growth, but I've seen examples where it's more than 100% on a yearly basis, primarily because definitely in those greenfield opportunities where, in the past data wasn't really stored because, there was no value for it, or, customers have now find ways to actually monetize it because the GPUs have made it more accessible to monetize it. So, the challenge is is that, you need an architecture that really can scale. And, at Western Digital, we ourselves, obviously we manufacture the drives ourselves, but we also have a flash division, right? So we also manufacture NVMe drives. So when you look at our customers, right, there's a fine balance. There's a balance between the flash tier and an HDD tier. And so today what we're going to talk about is how can we optimize, the NVMe tier so that you can accelerate your insights, right? So you can accelerate, the machine learning algorithms and get faster to new ways to monetize your data. That it's harder and harder to keep your data up and accessible because traditional environments, a lot of the data or these assets were actually stored on either on a tape environment, or they're stored in the cloud, or they're stored in lower smaller systems or not systems that are not necessarily fully accessible to all those new applications. So you have to find a way to easily access the data in a given notice, right? So, and when you access the data, what we're seeing today is that, it's no longer just, a terabyte or 5 terabyte or 10 terabytes. We're seeing customers pulling back literally petabytes of capacity into those machine learning algorithms, because for training purposes, they're no longer just looking at a single data asset, right? So they're not just looking at one collection of data sets. They're looking at a massive number of data sets. And here as well, as data becomes more competitive, or is being used as a competitive advantage, data gets exchanged across multiple companies as well. We're seeing today customers actually selling off their data assets, right, for real money to customers that are looking to use that data to train their models and make their applications more productive. So, as we call it, feed the beast, right, the GPU beast. Today it's been a big challenge. NVIDIA's done a tremendous job in accelerating workloads and specifically, training and inferencing. And if you look at the models that exist today, you're seeing servers that can host up to 16 GPUs today, and those GPUs, just to give you a reference point, internally within my organization, because I run solutions, we also test GPUs in our environment against our storage servers. We had a data scientist optimize their algorithm from 45 minutes to 1 minute, and this is a 45x increase, or 45 times faster, right? That his model was getting trained, and so that's a huge difference, because now you're talking about days or weeks of manpower, man hours that you can actually optimize. And so if you consider that one server can handle 16 of these GPUs, you can optimize a tremendous amount of time in your current applications. And so I've actually talked to HPC customers that are looking at machine learning today, and one of them in particular called out the fact that they had been able to optimize their application by 100x. It took them a couple of months to rewrite their application and their libraries, but once they were optimized to a GPU, 100x return was just phenomenal, right? So for them, it paid off tremendously. And so you're seeing a lot more of the traditional HPC environments as well augment their environments with the machine learning infrastructure. But the challenge there still lies into, how can I get the data to the GPUs? Because now you get these really powerful GPUs, right? As we call them, the beasts, that, can handle 45 gigabytes of bandwidth when they have, 800 gig Ethernet interfaces. But not only that, they just don't have enough capacity locally. And so you're seeing a lot of GPUs that are sitting idle. We've seen customers that have GPUs that are just sitting there for 30%, or 70% idle. So really right now it gets back to, how can I optimize not just my efficiency, but how can I actually actually get a better ROI out of these GPUs that I just purchased? Because, technology gets updated very quickly, right? So you want to make sure that you utilize it as long as you have for. So what we're seeing is that even in the latest DGX servers, if you look at NVIDIA, NVIDIA has now DGX2 out. Obviously you can take off the shelf servers, and we've seen customers that have tens of servers loaded with a GPU, each with a GPU. But you can buy these DGX2 servers that are basically a condensed version. They have up to 16 GPUs and they're optimized for performance. They can handle 100 gigabytes per second and millions of IOPS. But they only have limited capacity within that box, so that's a challenge. And so for us, it's been like instrumental to figure out how can we help our customers in optimizing those workloads. To give you an idea, like, even a GPU within my lab, and this is sort of like the low-end enterprise GPU, cost me around $7,000. So, it's not just the capacity, but also the latency that you can deliver at scale, right? Because as you buy into these larger and there's very expensive GPUs, you have to make sure that you can not just feed data to the box, but you can also feed it at low latency. And so, if you look at the traditional technologies that exist today, and, obviously at Western Digital, we manufacture all of these, right? You can go with a traditional SATA SSD, but that's very limited. As you can see, for SATA SSDs can get you 2.2 gigabytes per second in throughput, right? But that's not sufficient if you know that these boxes can handle 48 gigabytes, and definitely in DGX2 can handle 100 gigabytes per second. So and then if you look at the IOPS, very similar here as well. You're limited. So obviously the SATA SSD is not the best fit. And then when you look at the newer types of devices like NVMe, you get really high throughput because there's some really good benefits about NVMe, that just the protocol itself, that will contribute to high performance, lower latency and stuff like that. But there it could be limited because you only have so many PCIe lanes left for local flash, right? As soon as you start to install these GPUs into a server, there's only so many PCIe lanes that you have left to actually, store those SSDs in. So, the problem is, and this is very normal, right, is in every technology that, that you deploy, there's always one that's leaping, there's always networking that's getting faster than the CPU, or it's the other way around. In this case, the GPUs have sort of like outperformed the ability of us serving storage to those GPUs fast enough. So it's always a combination of finding the right balance between the performance, or the number of CPUs or GPUs you have installed in your environment, versus the networking capability that you have. Do you have 100 gig? Do you have a 10 gig networking interface? Or do you, what kind of fabric are you using then? Are you looking at Ethernet or InfiniBand, etc.? But it's always a combination of storage, networking, and compute, essentially. And so, as you deploy new architectures, right, it's always important to see and look as well on look at how that software stack that's managing these devices is architected, because today there's a lot of challenges in the existing ecosystem. So my responsibility at Western Digital is to identify new solutions that actually take full advantage of our technology. So our goal is to create, solutions that can help customers move faster and take advantage of our devices and our servers, because now we also sell storage servers under Western Digital. So as we look at trying to solve this problem, it actually starts first and foremost with the media. Obviously because we create the media. Because the media itself, specifically in this case, NVMe, gives you, that higher throughput that you need, right? You get more IOPS out of a single drive. So you get up to 1.2 million IOPS. 2, you get, more throughput out of a single drive. And 3, you get lower latency. Again, the 3 things that you need to get started, essentially. Now, why is NVMe important? It's not just because of the media, but it's more important because it has, it's really because of the protocol and the benefits that this new protocol brings with it. So first of all, it provides you with higher PCIe bandwidth than SAS or SATA, right? We're seeing up to 2x faster performance just in throughput from the get-go, and that's on a single device. Second, you get multiple parallel low latency queues. And why is that important? That's important because it supports more scattered I/O. So you basically have less overhead on the CPU. So the CPU can be used for other purposes. So you get, again, lower latency as well because of the direct memory access, and you get a lot more lanes, I/O queues that you can process. Just to give you a reference point, with SATA we had with SAS we had 254 entries per queue, and we have a single queue, right? So we have a single queue. And then with NVMe, if you look at the NVMe protocol, you can have more than 64,000 queues, each with more than 64,000 entries. So massive improvement versus SAS. And SATA is even worse because you can only get 32 entries per queue. So makes a huge difference, definitely to core architecture where you have, more CPUs or more cores, or more processors in general that you want to process against. So now, what's the challenge? The challenge is like, my team does a lot of testing and a lot of software-specific testing, right? So what we do is we work with the ecosystem, distributed file system, distributed block architectures, and you would look at the full, end-to-end workflow, right? So when you want to deploy an environment like this, it's very important that you have everything in place. That it's not just the media; it's the combination of the media with the network. And the challenge here is that the traditional interfaces like NFS are limited. The traditional architectures that you see out there are just not optimized for scale, right? They're optimized because they were based on a traditional SaaS, or SATA infrastructure. So now, you're sort of like optimizing. I see a lot of customers, they take an NVMe drive and they put it on their existing architecture, and they assume that they will get all the benefits. Well, the answer is no. It absolutely is not, because you have to almost rewrite your architecture from scratch to really take advantage of these benefits that I just talked about. So you need a multi-node architecture. That's one. Two, you need to be able to optimize your writes, your reads, that to the software stack, that and take advantage of RDMA and all these things that are sound easy on presentation or PowerPoint. It's very hard to implement. And so what we're seeing is that these traditional architectures will basically get to a certain point of optimization and then fall over and start to degrade and actually get worse. So, it's really important that as you implement NVMe, and I get that question all the times from customers, right? Okay, well, I got my NVMe drives, so just plug them into my existing Oracle server or my existing file system that I have. Will I get all the performance numbers that you talked about? The answer is absolutely no. So today, what we're talking about here with Excelero is exactly a solution that does take advantage of NVMe, and not only that, it can scale beyond a single drive, single node, etc. So we'll talk about that, and I'll let Josh talk about how we actually can extract the maximum ROI from NVMe with Excelero. Josh, I'll pass it on to you.
Thanks, Stefan. So those on the call have heard about NVMesh before. This wouldn't be new to you. The great thing is pairing it with the solution from Western Digital, so that you have world-class leading hardware and software. You put them together, and what do you get? You get a network of these nodes that you can put NVMe in, but share that NVMe pool across all your GPU servers, with all of them having access. And by the way, as Stefan mentioned, these GPU servers, whether you get them directly from NVIDIA in the form of DGX1 or DGX2, or you get them from a third party that offers specialized GPU servers, they all share something in common. And that is they come with a whole bunch of Mellanox networking, generally 100 gigabit networking, because the GPU workloads already use RDMA to be very low latency to go ahead and parallelize those loads. So when you've already got a very, very high network bandwidth device, in fact, you've got more network bandwidth on these GPU servers than you have to the local NVMe drives. That's the key thing we're trying to drive here. By disaggregating your NVMe into the Western Digital platform, you get a scalable NVMe solution that can be accessed by any GPU server with higher bandwidth over the network than if you had the drives locally. And if you're looking at terabyte size images from a 3D CAT scan, from very select satellite imagery, et cetera, and this is what you're doing your training runs on, you literally could have, if you have 1,000 images, you could have a petabyte of data to go through. And so you need this scale, you need that bandwidth to go ahead and process it. And you can do that with the joint solution we're promoting here, which is NVMesh, on top of the UltraServe 24.4N. So you get no performance penalties. In fact, you're getting better performance over the network than local. There's no storage choke point here. Other solutions have come out there and are telling you that they're scalable. And just remember that chart we saw a moment ago. They are scalable to a point, and then they fall over. NVMesh scales out to at least 128 nodes on a single volume, and then you can have multiple volumes. So you can scale out to hundreds of petabytes in a single cluster with no problem, and scale that performance at the same time. Now, but moreover, we want to make sure we add that you're also doing this not just with volumes that are striped or can be grown, but they also are protected. They're protected with RAID 1 or RAID 10 for the ultimate in performance. Or if you are a little bit more read optimized, you can do erasure coding. And with erasure coding, you still get all the latency, all the read bandwidth you're used to with NVMe, but you get a lot more efficient data protection this way, up to 2 drives or 2 nodes failing. So you have double protection there. And all of this is going to help you maximize not just your capacity and performance, but utilization. Because unlike drives that are local to a DGX, these can be used by everyone at any time. So you don't have drives sitting idle. And lastly, when you don't have drives sitting idle and you can use them from anywhere, it means any GPU anywhere can be used to its maximum efficiency because it's not out of space or it's not waiting for a copy to come over the network. Next slide, please. And we'll go much shorter on this one. This kind of gives you a clue of what you could do if you were putting out a big farm. You see you have NVIDIA servers, maybe these are DGX2s on the bottom, hooked into your switch, which again, you already have this. If you're deploying multiple systems, you already hooked into a 100 gigabit switch. So you have the network bandwidth there already. And then at the top there, you can see we have the UltraServe 2U4Ns. That can serve up to 80 gigabytes per second of bandwidth each at extremely low latency. Individual 4K transactions at under 100 microseconds. So this means for training, which is generally bandwidth intensive, you have plenty of bandwidth, both to initially get a data set on there, to read it faster than you could read local. And lastly, if you were also using these your systems for inference, which is generally more latency sensitive, you can use that very same data storage for very, very low latency inference runs. So you get the best of both worlds on an infrastructure likely you're going to have already. You're just going to get much, much better use of the NVMe that you're going to want to use for your data load as well. Let's go ahead. And what is that performance? I mentioned it briefly. If you were to fill a rack with these new Western Digital servers, you would get 1.6 terabytes per second of performance in a single rack. And if those of you on the phone are not used to numbers that big, let's make sure I'm not saying terabits, I'm saying terabytes. You're getting over 80 gigabytes per second per single server, and if you could fit 20 of those in a rack, you're getting 1.6 terabytes per second of bandwidth. So this is massive performance, massive scalability, because that's not even as big as you could go. You could go larger than this. You can go multi-rack if you wanted to. So the key thing here is, even if you don't need to scale that big, just remember in the back of your mind that you don't have a scaling limit. That's the beauty of NVMesh and WD together here, is that you can start with a single unit, 2U, 24 drives, and then you can grow that later and grow your volumes and grow your environment, all without losing any performance. In fact, as you add systems, you have linear growth at 80 gigabytes per second of read performance per unit. And the IOPS are also equally impressive. We're going into the hundreds of millions of IOPS per rack. Next slide, please. This is a little more about what this server looks like. It is actually 4 servers in a single 2U chassis, and each server sees 6 NVMe drives. Why is that important? Well, we're actually serving all these drives out over the network. And in each of these nodes, you can put 200 gigabit cards. So this gives you the network bandwidth you need. A lot of you may say, well, this looks exactly like a lot of 2U servers that are out there that take 24 drives. But many of those are single nodes in which you can only get 2 network cards, which means that you're seriously bottlenecking your NVMe drives. This server is unique in that it has that kind of this optimal balance. It has more network bandwidth than it has drive bandwidth, just by a little bit, which means you can extract every bit of bandwidth and IOPS out of those drives. That almost 20 million IOPS per one of these chassis, and up to 80 gigabytes per second bandwidth. So it's extremely performance dense. In fact, we believe it's the most performance dense solution in the industry right now. So with that, you can go ahead and scale. This is another slide on showing you how to scale, just making sure that we emphasize that it's not just about a single box. You can take multiples of these, hook them together. You hook it all together with your 100 gigabit network, and you can feed not just GPU servers, but other kind of servers in your environment. You can mix and match, and it's really all about choice. With an NVMesh cluster and this platform, you can feed all sorts of platforms here. Let's go ahead. This was actual testing we did in our labs on this unit, full of 24 drives. These were actually, as Stefan had in the beginning, this was on the SN630, where we went ahead and did multiple different tests, but wanted to show you the linearity and scale here. So within each of these bars, what you're seeing is 4 different tests where we increased the thread count. So within each set, so where it says 4K on this slide, we started with a lower thread count and then went to a higher thread count. And this was 8 clients against a single UltraServe 24-4N. So this is a single 2U box with 24 SN630 drives. And we increased the threads, and you can see that pure linear scalability in reads, going almost as high as 20 gigabytes per second of 4K. And as we move up to 8K, 32K, you see we increase the block size. And as we go to larger and larger block sizes, we're really doing a bandwidth test. And you can see where we just popped in the very end, we popped just over 80 gigabytes per second of read bandwidth. So true linear scaling performance as we increase the number of threads or clients. And then as we increase the block size, you're getting massive increases in bandwidth. So just showing you that you can get massive bandwidth and IOPS out of this in this testing. Next slide, please. Now, lastly, this goes back to something that was mentioned is many folks are doing their AI and ML with NFS. And NFS is great because it's easy. But NFS is still to this day, regardless of who you buy it from, it is a point-to-point solution. So there are folks out there that say, you know, well, each of our NFS servers can do a gigabyte per second using 10 gig, or they can do 4 gigabytes per second using 40 gigabit, et cetera, et cetera. But, and so if each one can do a gigabyte per second, and they give you 10 of these targets, they'll tell you that you can do 100, or excuse me, 10 gigabytes per second, at a gigabyte per second each. But this is likened to riding a bicycle. You know, I pretty easily can ride a bike at 10 miles per hour, and or if you like, 20 kilometers per hour. But if I have a group of friends and 10 of us can all ride at 20 kilometers per hour each, I could say in aggregate we can go 200 kilometers per hour, but I can't go 200 kilometers per hour. No one bike can. So it's kind of the same with NFS. What you want to do is you want to pick the parallel file system of your choice. And we work with almost any parallel file system out there, IBM Spectrum Scale, open source BGFS, to go ahead and truly let any one node get that maximum performance. So you can have a DGX2 really pulling 48 gigabytes per second into that server to feed those GPUs, not just 10 gigabytes per second or 1 gigabyte per second. So you can put the file system of your choice on top of this, and then you can scale both. So just keep in mind that the power of choice is very, very good. And if you don't want to do it yourself, we have ways, both Western Digital and Excelero, to put you in touch with the right integrator that can get you a complete solution out of the box, delivered to your data center, ready to go, GPU servers and the storage if you like. So just because there's a choice doesn't mean it's difficult. But we can make the absolute best solution for you. Next slide. All right, so is anybody doing this, all this stuff we're talking about? And the answer is yes. NVMesh and Excelero are very happy to have this reference customer named InstaDeep, where they have deployed just this. They had DGX1s and just simply realized that they either had the problem that their SATA drives were not fast enough inside the DGX ones, or they didn't like the fact that in a workflow they had to copy. They had to always copy the data and copy it in, use it, wash, rinse, repeat. So InstaDeep went ahead and deployed NVMesh on disaggregated storage, and they got what performed better than local storage inside the DGX. And moreover, it's more highly utilized because the GPUs are not waiting for data to be loaded. They can go ahead and get much better usage out of their GPUs, which, as Stefan mentioned, are the most expensive part of what's going in your data center these days. So if it's the most expensive, to get maximum return on investment, you want to have that as highly utilized as possible. And we enable that for InstaDeep, who is providing GPUs as a service for customers. So it lets them serve their customers better by giving them higher performance, less runtime, which is good for the customer, and of course, highest efficiency levels for InstaDeep themselves, which is lower investment and capital for them. Next slide. We also, if you're on this call, we're talking about AI and ML, but these things are really analytics. And there are still folks out there that use some traditional solutions, such as Oracle. Oracle makes a product, in fact, made for analytics. We're very happy to have a customer who recently presented at the latest Flash Memory Summit, showing how they slashed their capital expense and their operating cost and licensing. So they slashed their licensing cost by 62% because they needed so many fewer Oracle rack nodes to do the same amount of work on their analytics runs. So analytics via Oracle, of course, is a more traditional use case, but very, very spread out there. So if you have this, you can really, really slash not just your capital outlay. They went from spending $2 million on storage to spending only $500,000. So that's a huge reduction. In fact, maybe that should be the title of this slide. We'll see. They reduced their licensing costs for Oracle by 60%, but they also reduced their storage spend tremendously. So down to only 25% of what they were spending before. And getting the same performance, by the way, or better. So that's the key takeaway here. Go ahead and use this platform, the WD platform, to get the ultimate in performance density, and we'll reduce your costs for you, make you more efficient. And with that, I will hand it back to Stefan.
Thanks, Joss. Yeah. So as everyone has seen by now, obviously we're not just talking about numbers. We're actually doing those performance tests in the lab. This is real. This is something that's deployed in production. And, we have a strong, relationship with Excelero that goes beyond just a checkbox on a piece of paper. So we actually have, equipment in each other's labs, and we work very closely together with the ecosystem partners because it is so important to align, as I mentioned in the beginning, right, the software stack to the hardware, because today customers are looking for a solution. They're looking for an offering that can actually solve a problem and not just not just components. So most of us know us, but as Western Digital is leading the NVMe revolution because we are manufacturing. We have huge fabs, and we are very much optimizing and tuning our NVMe across the stack. So whether it's machine learning or edge solutions, our devices go into cars and in laptops and in phones, etc. But here we're talking about the data center, and even in the data center, there's a lot going on. So NVMe over Fabric, etc., is a big topic in a lot of data centers. So we have solutions for pretty much all of these. So if you're interested in more information, please contact us because we have experts in all of this, and we can help you with the sizing exercise. But in summary, I hope you've seen by now that it's a combination of NVMesh plus Western Digital that can help you scale your architecture and deliver performance at scale. And not just that, it could actually help reduce your licensing cost in certain environments like the Oracle environments. We're seeing that in virtualization as well. We're seeing that in any application that is sort of hyper-converged. And we're seeing it in machine learning, where it's extremely expensive to to be able to run those GPUs at full capacity. So with this solution, right, you don't only get the ability to scale, but also you get built-in data protection, as Josh mentioned, and you get the best of both. You get our interested in any of the details, because we have only shown you a snapshot, right? We've shown you a peek into all the performance numbers and the sizing details that we actually have built together. So we can set up, by all means, a follow-up conversation with yourself or anyone in your environment that wants to learn more, and we can walk them through sort of like the best practices and our recommendations on how to size up or scale out with this architecture. So with that, we'll open it up for questions. And I saw there were some questions on the Q&A. Tom, I don't know if you can guide us through the questions for today.
Yes, Stefan, I just got in a very interesting one from Yuri, if I pronounce that correctly. Question is a 2U4 node server still needed with new AMD single socket 128 lane PCI v4 systems? And he adds, he would imagine that a single socket AMD Rome platform can push as much or more data as the Intel at a lower cost.
Oh, good question. I'll have to follow up on that. Today, I mean, the 2U4 node is available from Western Digital. That's what we're selling today. Obviously, as new architectures with, the AMD, as new AMD architectures come out, we can review that. Today, we're focused on Intel, but that's a good option. Actually, it's very interesting. I need to do the calculations there to see if this would take the 2U, the 4 nodes architecture, if that would change it. But so for us, I mean, we're flexible, right? This is one of our servers that we offer today. We have 5 or 6 types of servers in our portfolio, and Excelero has been certified on 2 of these platforms. This is just one platform we're demonstrating here. So Yuri, I'll follow up on that as well to see if I get some more details from our PM team on this to see what the future looks like there.
All right. And then I had a question from Phil, and folks, please do keep sending questions. Q&A is still open. Very happy to take a few more. But Phil, and this one is probably for Josh. He was referring to the GPU architecture slide Josh was talking to, and he was asking whether this architecture also helps with CPU-based workloads. Josh?
The answer is resounding yes, and it works. In fact, depending on your workload, you could use this WD server, which in its own right is a very powerful server. In 2U, you get 4 nodes, and each node can be a dual socket CPU. We were talking about it in GPU and AI workloads as disaggregated storage. But you could also put more performant CPUs in this, and NVMesh doesn't use any target side CPU at all to share those NVMe's. So that means you could go ahead and use it in a converged mode for traditional CPU-based workloads, still share all the NVMe and get all the performance benefits and unlocking any kind of performance bottleneck on your storage. But yet you could have powerful CPUs in there and quite a considerable amount of memory, and go ahead and use this in a converged way, and it would also accelerate CPU loads. If you didn't want to do converged, you also could use it exactly as we showed in the slides and have it be disaggregated. And of course, that's going to go ahead and open up, if we mix this with kind of the other question that came up, if you look at a Rome-based platform with 64 cores on a single socket, you're going to need tremendous parallelism, and disaggregating your NVMe and having access to that and all the queues, having the aggregate available of the depth of the queues and the performance of all the drives would really unlock such a CPU like that in a traditional CPU workload.
All right, thank you, Josh. And I see 2 open questions. Phil is adding another question. How does CPU load minimize latency to none, I guess it is.
I'm not
sure from it, yeah.
I don't see the update to that one.
He posted it as a separate new question.
Is GNOME supposed to be none? And
I guess.
and we can never get to no latency. But what we can do is, if you look at a given NVMe drive, and the SN200 from WD is still among the best performing NVMe drives in the industry. But it, like other NVMe drives, is when you start to hit it at 40 to 50% of its capacity, its latency starts to spike. So what we can do by spreading the load, having a striped volume go across multiple drives, is we're hitting each individual drive with a lighter load, which means it's keeping its latency lower, which also means that then you can, against one of these units, the UltraServe 24N, 24 drives, you can hit that. We've talked about these gigantic numbers, but if you're hitting it with only 1 million IOPS, and I am saying that sarcastically, if you're only doing 1 million IOPS, 4K, 8K IOPS, you're still going to keep your latency response time extremely low. Definitely under 200. I'd have to look at the actual numbers, but I would bet it's under 150. So we can never get that latency to none, but you can drive extremely high workloads at the lowest levels of latency, lower than you could get locally in the box. Because if you had your NVMe local, your processor would be spending so much time doing I/O and through the drivers in Linux to those drives, you'd actually increase your latency because of CPU contention. But by going out across the network to an aggregate of NVMe drives, we can keep that latency as low as possible, which means that any load that's parallelized, and in that parallelization has some serialization, meaning that we're going to go ahead and drive that load down. We're going to take the time down, and as we can never get to zero, but of course, as you want to get arbitrarily close to zero, that's going to help your load. I hope that answered the question.
All right, we'll see if there's another follow-up. Then I see a few related questions. Stefan, they'll probably be for you. Laura was asking whether servers come with different drive types. And then Michael was asking what size of drives are in the servers. And Kevin was asking how many drives are in each server.
Yeah, so there's 24 drives in a server. Actually, I have a slide which I can go quickly through. I can show you that. Give me 1 second here. Basically, if you look inside the box, it's a 2U 24 with 4 compute. As we said, we have 2 drive types right now, SN620 and the SN640. We also have the SN200. The range of SSD capacity. So we basically have different compute capabilities as well. So you can, depending on if you want to run more applications on the server itself or just use it as a target, you can go for a higher end compute versus a lower end compute. And then you have different sizes. So depending on the drive type, we have 3.2 terabytes to 7.6 terabytes. It sort of depends. But I can send a data sheet and a solutions brief after the call. Well, let's maybe follow up with our solutions brief and our data sheet so everyone can see what options we have. With Excelero, we actually worked on a couple of profiles. So we didn't really go through this, but we have a low end and a high end. And we'll share that with the team, how they're configured.
All right, thank you, Stefan. And then I got 2 other related questions. Mike was asking how he could buy the complete solution. So I'm assuming that means the box with Excelero and NVMesh. And then Chris was asking whether he can buy the server directly from Western Digital.
Sorry, the server can be bought through the channel. So all our distributors and Western Digital VARs and integrators can actually buy the server from Western Digital. And so you work with your local integrator, with your local distributor. Anywhere where you can buy a drive essentially from Western Digital, you should be able to buy a Western Digital server. What was the first question, Tom?
The complete solution. So
the complete solution. Yes. Okay. Yeah. So that comes. So again, here as well, we work with Excelero in the field, which means that we meet in the channel. So look at your integrator, and the integrators will integrate Excelero with the Western Digital servers. We don't resell Excelero. We do all the testing and we validate all those configurations together. but we don't resell it. That happens with your local integrators.
All right. That was the last question I got, gentlemen. I would like to thank the attendees for attending. And Stefan, Josh, thank you very much for preparing this and for presenting this very interesting presentation. Folks, if there's any follow-up questions, please do not hesitate to contact us. You have my email address, or you can just send emails to info@excelero.com or josh@excelero.com, and we will happily pass the questions to Stefan if needed. Again, thank you very much, and I hope to have you on the next webinar. Bye-bye.